This tutorial will be on free body exercises, mechanical equilibrium. This can be found in your packets, and so make sure that you have that one. We'll go ahead and get started on the first problem, which is LM2 equilibrium. Okay, our first problem is LM2 equilibrium. As you can see, it's like a rock hanging off of a string that's attached to a ceiling. And this is an equilibrium. And with all of these problems, the first thing I want to draw is my gravitational force. So I draw that, and I'm going to label it F sub g. My other force, my counter force to this, is going to be the string that's going to be pulling up. And that string that's going to be pulling up will be exactly the same amount of force, but in the opposite direction. So I go straight up, and I'm going to label it F sub t because that's my tension force. So this force and this force are equal, but they're going in opposite directions, which puts it into equilibrium. All right, so our next one is LM3, friction prevents sliding. So we're going to have frictional force preventing it from sliding. Sliding will go this way, so the frictional force has to act in the opposite direction. But before we do that, we're going to have to draw a couple of forces. First one, as always, we want to draw our gravitational force. So we label that F sub g. Our next one is our normal force. Now make sure when you're making your normal force that you're going to go perpendicular to the surface. The perpendicular to the surface goes something like that. So I'm going to make my normal go perpendicular, which will look like that, which is F sub n. And then finally, I want to make my frictional force, which is going to go parallel to the surface, but in the opposite direction that it would normally go. And make sure you label that F sub f. So now we have created a balanced force, gravity pulling it down, normal force pushing it perpendicular to the surface, and frictional force preventing it from sliding. All right, here is LM4, which is also in equilibrium. We've got a rock suspended by two strings. Now both these strings make the same angle, so they're going to have the same tension. And we'll get to that in just a second. But first things first, I want to make sure that I draw my gravitational force. Okay. And then I'm going to draw my tension. So I'm going to have two tension forces, one going in this direction and one going in this direction. They're going to be equal in size. I'm going to label this FT2, and this will be FT1. And they're equal, but I want to point out some things. So you see, if I were to take this vector right here and apply it to this right here, we would see that they would combine and make a vector, an imaginary vector that went up like that equally matches the gravitational force that's going down. So we've got to be aware of those things whenever we are drawing a free body diagrams. So this is what LM4 looks like. All right, here is LM5, which is also in equilibrium. Now, it's very similar to the last one, except you can see both of these lines, or cords, or ropes, make different angles. And so we got to pay attention to is the center of mass. Is the center of mass more over this line, line 1, or is it more over this line, line 2? Now, if you see here, we draw it straight up, it's closer to this one. So this one's going to have our larger force, and this one will be our weaker force. So as always, we want to draw our gravitational force going straight down. And then we also want to have a force going up, which is just a little bit longer, FT1, than the one going in this direction, which should be a little bit shorter. And there we have it. LM6. We have a rock that's on top of a surface. So let's start out with gravitational. And because it's on a flat surface, it makes it really easy. You just draw a line just going straight up because that happens to be perpendicular to our surface. And they're an equal and opposite. It's an equilibrium. Done. All right, LM7, also in equilibrium. Here we have a rock on a surface, and it's also being suspended by a string. Starting off, gravitational force going straight down. We have normal force going perpendicular to the surface. And then finally, we've got tension that's going in the direction of the string. All three of these forces should be in equilibrium and form a balanced situation. The forces going down are equally matched by the forces going up. The forces going to the right match the forces going to the left, so on and so forth. LM8, we have a rock that is being supported by two surfaces, so we'll have two different normal forces, and we're going to pay attention to where the center of mass is. Now notice the center of mass is more on this surface than on this surface, so when we're drawing it, we want to make sure that that one is just a little bit longer. In the meantime, let's go ahead and draw our gravitational force, then our normal force 1, which is going to be a little bit longer, simply because more of the weight's on there, and then our normal force 2, which will be just a shy smaller because less of the weight's on there. And there it is. Our last one is LM8, which shows a rock that is sliding down an incline, and it says it's in equilibrium. So the equilibrium tells you that everything is in balance. So we do have a little bit of friction, and the friction is causing it to go down at a constant speed. So I'm going to start out with gravitational force. Then we also have normal force. And now we have to balance out the gravitational force and the normal force with the frictional force, which is going to be going up the incline like so. And there's our frictional force, so this puts the whole thing into balance. And thus concludes page 1 of the free body diagram worksheet. Good luck, guys.